Hey, today we're going to talk about exponential applications models. So today we're going to use two formulas. The main one we're going to use is the compound interest formula. And this is a financial equation that you can use to either maybe if you invest your money into a savings account and at like a certain interest rate, this would be the formula that banks might use to tell you how much money you would make each month or each year, depending on how many times they will give you that interest. Also, it could be like a credit card. They also will charge you interest for borrowing money if you don't pay it all off every month, and they usually charge you per month. So our first formula we're gonna look at is this compound interest formula, where P is the principal or the amount down or borrowed is another way. So you can put amount down maybe into a savings account, and it could earn you money at a certain percentage, and they could, after a certain time frame, give you that money and put it back into your account so it grows. Or borrowed, you might use a credit card, and you might borrow $1,000, and then they're going to charge you interest if you don't pay it off every month. Your rate is the rate that they're going to charge, or that you'll be getting back to your account. And N is the number of times the interest will be charged per year. Sometimes, like a account is usually yearly, so they'll look at how much money you've had in your savings account for a year and then give you like a 3% interest back into your account. A credit card will usually charge you interest every single month, so 12 times a year. And we'll look at how this compound interest formula works in the next section. So this is our first formula that we're going to be using. And the next one is as this time, how many times you can be charged interest per year. Obviously, you can be charged once per year, or twice per year, 3 times per year, 4 times per year, and you can keep going. And what happened is mathematicians started saying, well, what happens if we just create the number of times to be infinite? So every second, every 1 minute, we charge you that interest. And so what they did is they took this n, and what they called the n was, they said, we're going to call that mr. And so anytime I have an n, I'm going to write mr. I'm just going to replace it. And then what that created was this scenario where now my r's canceled off, and I'm left with 1 over r, and then I have 1 over m, excuse me. And then I have m, and then all of this is going to be raised to the RT. And then what, if you notice inside of there, is this is the same equation that generated the irrational value of E. So instead of having 1 plus 1 over m raised to the m, we're going to replace that with the value of E, remember, which was about 2.718, and to the RT. And this is what we're going to use is our continuously compounded interest. So continuously. Okay, so that means it's going to be compounded at such a small rate or time interval, it really doesn't matter anymore. Okay, so we're going to look at these two formulas. We're going to look at the continuously compounded interest and the compounded interest, and we'll take a look at this. Okay, so that brings us on to our next page. And we are going to look at these two. So A is equal to E, and the E to the RT. Remember, E is just that irrational. And this scenario that we're going to go over is credit cards. So this is not going to be one where we're going to be saving money. This is going to be one where we owe money. So the first thing we're going to do is we're going to talk about a shopper that borrowed money on the credit card. So suppose that you make a purchase for $1,000 on your credit card, and that credit card charges you about an 18% annual percentage rate, which is about what they do. That's actually not a bad rate. Sometimes it's 25%. And we're going to find the account balance if you didn't pay it after 7 years. So I'm going to say A is equal to the amount borrowed was $1,000. 1 plus my rate is 0.18. The number of times compounded is going to be 1 year on this one. So this would just be 0.18. My n would be 1. So 0.18 divided by 1 is just 0.18. And then 7 years. My n is 1. So 1 times 7 is 7 using this equation right here. And I'm just going to plug that into my calculator. And let's see, 1,000 times 1.18 raised to the 7, I get $3,185.47, round to the nearest cent. Okay, so the next one is if the interest were charged at the same 18%, but they did semi-annual instead of once a year, the card would have charged you 9% twice a year. Let's find that same balance after 7 years. So now I'm going to use the same equation, but instead of it being 1 year, now notice the same percentage, but this is where my n is twice, so 2. So now you see where that 9% comes from, right? So I have my 0.18 divided by 2, and I'm getting this from the formula right above. And then I'm going to raise that. Well, this is going to happen for 7 years. Well, every year I'm doing it twice. So it's going to actually end up being 14 times. And so what I'm going to do is I'm going to plug this into my calculator. And so I might show you how that I would plug this into my calculator. I'm going to do 1,000 parentheses 1 plus another parentheses 0.18 divided by 2, because it's going to happen twice a year this time. And then I'm going to end my parentheses. And then I'm going to raise that to the 14. And then there's my answer. So it's $3,341.72. So you notice that it charges you more money if they compound your interest twice, because what's happening is the first time, halfway through the year, they're charging you an interest, and then that creates a balance of more than $1,000. Then at the end of the year, when they do charge you your interest the second time, your amount that you owe is more than $1,000. So they kind of double dip on you by charging you some of the money that you owed from the interest at the halfway point. So now that what we're going to do is we're just going to kind of look at what happens if we keep compounding more often. So annually, how many times? 1, interest rate, period. We already calculated this work, right? So I'm just going to write. And we'll just, this was our 1,000. Just going to rewrite it semi-annually. This is the same one that we did up here, so twice. Interest rate per period, that'd be 0.18 divided by 2, which is 0.9. And then if I was going to plug this in that we already did, 1 plus 1.8 divided by 2, and this was going to be 14, and then we got 3,347. Okay, and now we're going to keep going. So what happens if we charge the interest quarterly? That would be 4 times a year. So what happens is I would break up my interest into quarters, which would end up being 0.05. So I would have 1,000, then 1 plus 0.18 divided by 4. And then now I would have 4 times 7, which is 28. That's a multiplication. So now I'm going to plug that back into my equation. So I don't know if you know this about your calculator, but if you hit second button and enter, it will regenerate the equation you just had. So now I'm just going to say 4. I'm going to turn this to 28, and I'm going to hit enter. And now I get 3,429 and 70 cents. I already forgot it. So notice the first jump, I went up about 200, and the second one I went up about 100. So I'm going up less even though I'm compounding more. So monthly, this is what a credit card would do. And so I'm going to take 0.18, and that's my yearly interest, and I'm going to split it up into 12s. And I get 0.015. And then 12 times 7, which is 84. And now I'm going to go to my calculator, and I'm going to put second entry, and I'm just going to use those two numbers. So now I'm doing it monthly, and this will be 84. I'm going to hit enter. Well, something went wrong there. Oh, I see what I did wrong. Somehow I got rid of my last parenthesis. Let me get that. There we go. Okay, so now I have 3,492.59. Okay, the next that I'm going to look at is weekly. So how many weeks are there in a month? So there's 4 weeks in a month, and then times 12, we have 48. 0.18 divided by 48 is 0.00375. You can see why the equation is a little bit more friendly. I'm not dealing with that. Let's just put 0.8 divided by 48, and then I have 48 times 7. I'm just going to write 336. Now I'm going to go back to my calculator, and I'm just going to put my 48, second enter. This is going to, my time is going to be now 36. Change this to 48. Enter, and I get 3,517 and 12 cents. And then I'm going to say, what if I do this daily? So that's 365 approximately. 0.18 divided by 365. I'm not going to write that decimal. It's going to be too nasty. I'll let my fraction take care of that. So 365. And then 365 over 7 years. That is going to be 2,555, and then back to my calculator, and let's take a look. I'm going to say 2,555, and then this is going to be 365. Okay, enter, and it looks like $3,524.33. And there's a point to this. So if you notice, as I'm compounding, I'm charging my interest more and more over time, that there is a pretty big jump between, let's say, annually being charged and weekly. However, between annually, between weekly and daily, there's hardly much of a difference. So it might be off by about $7. So what if we said continuously? So continuously means infinitely, many times. And that's when we're going to use the equation PERT. Okay, so PERT is going to be P, or A is equal to P e to the RT. Okay, so I have 1,000 E. Now what is my rate? My rate is 0.18 and then times 7. And this is my compounded continuously. So I'm going to go to my equation and I'm going to put 1,000 second and the ln button, and then I'm going to put 0.18 times 7. I'm going to hit enter, and then notice if I do it infinitely many times, I'm going to not get much different than it was if we were doing daily. So even if I brought it down to the millisecond. Okay, so this one is $3,525.42. So what is the difference between monthly, right, and daily? So we're going to subtract those two values, get $3,524.33 minus $3,492.59. That's going to be about $31.74, and that's over 7 years. So that's not even that big of a change. If you think over 7 years, that's how much extra money you're going to be charged. Now, if I do daily versus continuously, so $3,524. I have $1.09. So notice the more times that you start compounding this, or how many times you're going to charge the interest over a year, really starts to wash away, even between daily and continuously, meaning at every millisecond, every second. So here is a breakdown of the financial models, our two equations. One, if you're going to break down the interest monthly or daily or semi-annually, you would want to use this compounded one. If you want to take the interest and you want to continuously compound it, then you're going to use the A is equal P to the ERT. And I'll have some homework set out for you on Canvas.